Hi, my name is Jaima, a computer science student from Algeria. This is my final project of CS50's Introduction to Cybersecurity. You can find more of my work on Github under Feddane, and my edX username is Jaima_24. I'm recording this video on September 16th, 2024. During this presentation, I will guide you through the topic, covering the following 6 titles. I will conclude with a summary of our findings. The subject of my project is the new Android Trojan SomniBot and how it evades detection with clever tricks. This article was posted on the Hacker News on April 18, 2024. I chose this topic because I'm an Android application developer and I'm really interested in learning how to secure my apps against advanced threats like SomniBot. Understanding these techniques not only helps me improve the security of my own applications, but also directly relates to the principles and the practices we've studied in this cybersecurity course. So, what is SomniBot? SomniBot is a sophisticated type of malware specifically targeting Android devices, particularly common among users in South Korea. It operates covertly infiltrating devices to extract sensitive data without the user's knowledge. This Trojan is notable for its cunning methods to evade detection, making it a challenging adversary for cybersecurity professionals. Every Android app comes with a manifest XML file, which is Android manifest.xml, that's located in the root directory and declares the various components of the app, as well as permissions and hardware and software features it requires. Knowing that threat hunters typically commence their analysis by inspecting the app's manifest file to determine its behavior, the threat actors behind the malware have been found to leverage 3 different techniques to make the process a lot more challenging. The first method is called invalid compression method. When the Android system unpacks an app's files, it uses a library called libzip archive to check how the files are compressed. Normally, only compression methods like 0x40 or 0x308 are accepted. However, SomniBot uses a different method like 0x305, which tricks this library into thinking the file is okay to install even though it's not following the usual rules. This trick has been used by other bad apps since April 2023. Secondly, the second method is called incorrect manifest file size. So SomniBot misleads security measures by falsely reporting the size of its archived manifest file. By providing an exaggerated file size, the malware ensures that the manifest parser ignores additional overlay data that would typically exceed the valid file size. This helps SomniBot slip past security checks that would normally catch this kind of trick. The file technique has to do with utilizing long XML namespace names in the manifest file, thus making it difficult for analysis tools to allocate enough memory to process them. That said, the manifest parser is designed to ignore namespaces, and as a result, no errors are raised when handling the file. So, all these 3 methods ensure that the application will be successfully installed into the device. Once installed on a device, SomniBot established a connection to a predefined server address controlled by the attackers. It communicates using the MQTT protocol, a lightweight messaging protocol ideal for IoT devices and mobile applications. SomniBot collects and uploads sensitive information such as device metadata, context lists, photos, and videos at frequent intervals every 5 seconds. It also exhibits persistence by restarting its malicious services every 16 minutes if terminated, ensuring continued data exfiltration. Additionally, it hides its app icon, making it difficult for the user to uninstall the app. A unique feature of SomniBot is its ability to search external storage media for specific file types .key or .dir files containing digital certificates used in South Korea for government and banking transactions. This makes it particularly dangerous and sophisticated compared to typical Android banking malware. Earlier this year, the Kamsky Group used a similar tactic with their Troll Stealer malware on Windows systems. Both malware types focus on stealing digital certificates, highlighting a trend in targeting secure authentication methods. SomniBot has significant impacts on both personal and system security. It can steal sensitive data such as contacts, messages, photos, and videos, leading to privacy breaches and potential financial loss if it accesses banking information and digital certificates. The malware also affects system performance by running persistent background services that degrade device speed. To mitigate these risks, users should regularly update their devices and apps, download software only from trusted sources, employ reliable security software, and carefully manage app permissions. Additionally, Google has stated that no applications containing SomniBot were found on the Google Play Store. Android users are protected by Google Play Protect, which scans and blocks known malicious apps, even those downloaded from outside the Play Store. To end this presentation, it's crucial to stay vigilant and deploy strong security practices to protect against evolving threats like SomniBot. I'd like to extend a heartfelt thank you to David Mellon and all the staff for their guidance and support throughout this course. Thank you for your attention.